What do you call a man who spent all summer at the beach? A tangent. Get it? A tangent. Anyways, we will be studying tangents today. What the heck are those? Well, trigonometry, which is what we're starting, the very basics of it, studies relationships between side lengths and angles of triangles. For right triangles, each angle has an opposite leg and an adjacent. Adjacent means next to. The hypotenuse is not considered an adjacent leg. First of all, it's not a leg, it's the hypotenuse. And the way to find it is that it is always opposite the 90-degree angle, which makes sense. The hypotenuse is the biggest. It's going to be opposite the biggest angle in a right triangle. So we're going to go ahead and complete this table. But before I do, let me go ahead and mark up these triangles to make it easier. So I'm going to mark my right angles and then the hypotenuse, which is always opposite the right angle. Then I'm just going to go ahead and mark a set of angles and their opposite sides. So the yellow angles are opposite the yellow sides, and the magenta angles are opposite the magenta sides. So for triangle ABC here, for angle A, the side opposite is BC. For angle A, the side adjacent to it, it's not the hypotenuse, it's going to be this leg here, it's AC. And the hypotenuse is AB. For angle B, which is the magenta angle up here, its opposite side is AC, and the adjacent side is BC, and the hypotenuse is still the same, it's AB. Now let me move over to this triangle on the right for the 30-degree angle, and I'm going to fill in the sides. You should remember these from your math chart. The hypotenuse is 2, and the long leg is square root of 3. So for the 30-degree angle, the opposite side is 1. The adjacent leg is square root of 3, and the hypotenuse is 2. For the 60-degree angle, it's the opposite. Square root of 3 is the opposite side, 1 is the adjacent leg, but the hypotenuse is still the same. It's 2. Now coming to our 45-45-90 triangle, we can fill these in from our math chart. And the opposite leg in this case, well, it's going to be 1. And the adjacent leg is 1. So this is one of the few, this is the only instance with this isosceles right where both of these will match. And the hypotenuse is square root of 2. So the tangent ratio, we've described which ones are opposite and which ones are adjacent, which legs, and which are the hypotenuse. Now we're going to make a ratio between the opposite leg and the adjacent leg. Okay? So using the same triangles before, again, I'm going to fill in the opposite and adjacent. So for the 30 degrees, it was 1 and square root of 3. Tangent, oh, let me scratch through that. That shouldn't say hypotenuse. That should say tangent. All right. So tangent, pretend I can write, is going to be the opposite over the adjacent. All right. So it's going to be 1 over square root of 3. Now I can go ahead and rationalize that denominator by multiplying by square root of 3 over square root of 3, which will give me square root of 3 over 3. All right, for the 60-degree angle, the opposite leg is square root of 3. The adjacent leg is 1. So that's square root of 3 over 1, which is pretty simple. That's just square root of 3. For the 45-degree angle, it's going to be 1 and 1, so it's 1 over 1. So tangent of 45 degrees is 1. Again, tangent of 30 degrees is 1 over square root of 3. Tangent of 60 degrees is square root of 3 because it was over 1. And tangent of 45 degrees is 1. So what if I asked you about tangent of 90 and 0 degrees? What would that be? Well, let me take my slider, assuming I can click on it. There we go. Click on it. There we go. I can adjust the angles here. And you can see basically what's going to happen. This shows the length of the adjacent leg to this angle and the opposite leg. So if it was 0 degrees, let me see, does it go all the way down to 0? Yes, it does. The adjacent leg would be 0, and the opposite leg would be 1 in this case, because I have a 1 for the hypotenuse. So tangent would be 1 over, tangent of 0 degrees, its opposite over adjacent would be 1 over 0. That would be undefined. Actually, it's opposite over adjacent. So opposite is 0, and adjacent is 1. So it'd be 0 over 1. So tangent of 0 degrees is 0. Moving up, we go to 90 degrees. Well, in this case, the opposite leg is 1 and the adjacent leg is 0. So then you have 1 over 0. 1 over 0 is undefined. So tangent of 0 degrees is 0, and tangent of 90 degrees has no value. Your calculator, if you're in degree mode, will choke on tangent of 90. So you can use a tangent ratio to find an unknown leg if you know the angle and either the opposite or adjacent leg. All right? So to find missing legs of triangles, 1, make sure your calculator is in degrees, not radians. All right? Highlight the known side. Is it opposite, adjacent, or hypotenuse? You need to know which one it is. Highlight the unknown side in a different color. Honestly, I just tend to highlight my triangles to match the angles. So I highlight them all. Set up an equation where one side is the tangent of the angle and the other is the ratio. So you're going to say tangent of angle equals opposite over adjacent. All right? Solve for the unknown. You can put a 1 under tangent and that'll help you cross multiply. Use the calculator to find your approximate answer if necessary. All right? So in this example, we're going to find NL, and we're going to use, since you don't have calculators at home necessarily, I'm giving you some tangent values that we'll be using later. The only angle I really have here is 55. I do have the 90, but we almost never use that. All right, so I've got my hypotenuse, which is opposite the 90. 55 is opposite the x, what I'm looking for, and the adjacent leg is the 8 centimeters. So I'm going to do tangent is opposite of adjacent. So tangent of this angle here, 55 degrees, that goes inside of the tangent thing, equals x over 8. All right? So it's tangent of the angle equals opposite over adjacent. Now I'm going to go ahead and put a 1 underneath to make it easier to cross multiply. And I have 8 times tangent of 55 is x. Now normally you would get your calculator and go 8 times tangent 55 and have it spit it out. But since you may not have one at home, we're going to use the value I looked at. 8 times 1.43, that's an approximation, by the way. So I've got about 11.44 centimeters is x. Okay, in this example, here, let me go ahead and mark my hypotenuse. I've got my angle, its opposite, and the adjacent. So in this example, it's slightly different because before I was looking for the opposite side, and that is the easiest problem for tangent. Now I'm looking for the adjacent side. It's only a touch more complicated. So I go ahead and say tangent, pretend it stays, is tangent of this angle, 70 degrees. Now, it's not tangent times 70, it's tangent of 70. Kind of like you have square root of 7 instead of square root times 7. So this is what you're taking the tangent of, equals the opposite, which is a 25, and the adjacent, I don't know it, so I'll use x. I'm going to put a 1 underneath to make it easier to cross multiply. So I get x times tangent of 70 is 25. Go ahead and divide both sides by tangent of 70. You can do that. And if I were asking you for an exact answer, it would be 25 over tangent of 70. And you are expected to be able to tell me this part right here before using your calculator. Now we use our calculator and we say, oh, tangent of 70 is about 2.75. So we divide that and your answer is about 9.1 or 9 1/10. So for further reflection, how can you tell which side is the hypotenuse? Remember, it's always opposite the 90-degree angle. It should also be the longest one. How do you know which leg is opposite and which leg is adjacent? So for a given angle, it's going to depend which angle we're talking about. So for a given angle, you go across from the angle, and that's the opposite. Right next to the angle, but not the hypotenuse, that's your adjacent. Which side is not used for tangent? We didn't use the hypotenuse at all. We'll be using that for sine and cosine in our next lesson. And how to use a tangent ratio to find missing legs. You set up tangent of the angle equals opposite leg over adjacent leg. You set that up as your equation, put your little 1 underneath, cross multiply, and you're all set.